Hello, guys, gals, and non-binary pals. I just wanted to take some time, and let me fix my screen because it just got all messed up. There we go. Yeah, I just wanted to take some time to go over scientific notation, and then I'm either going to probably make another video on how to solve related equation problems. So first, scientific notation is how we take very large numbers or very small numbers and make them manageable. So, for example, the speed of light is written as 3.00 times 10 to the 8th meters per second. Now, if we break this down a little bit, what it becomes is 3.0 times 10 to the 8th. So 10, or 1, with 8 zeros. 2, 3, 4, 5, 6, 7, 8 meters per second. Oh no, I didn't put on a new layer. Oh, woe is me! Everything is awful now. It's not that awful. It's okay, guys. Don't worry. Oh, there's a new layer now. There we go. Switch. There we go. And that comes out to 3, 1, 2, 3, 4, 5, 6, 7, 8. So 300 million meters per second. That's pretty stinking fast. But that's a big number. It took me a while to write that. So writing this is much faster. If you want to write a very small number, let's see, to use an example, it's not going to be too atrocious. Let's say, I'm going to use different colors, you can tell the difference. Let's say you had 4.99 times 10 to the negative 7th. Well, I'm going to 4.99 times 10 to the negative 7th is the same as 4.99 times... And here's where it gets tricky, because when you have that negative, it basically means you're putting... Having a negative exponent is the same as basically doing this. And setting it up like that. So it's kind of inverting what you have. So it's saying this is an inverse of that number. So you have 4.99 times 1 over a lot of zeros, 7 specifically, 1, 2, 3, 4, 5, 6, 7. And what we're actually going to end up doing is then dividing 4.99 by 10 million. And what you'll get when you do that is 0.123456499. And you'll notice there's only 6 decimal points here. That's because when you have 4.99 and you move a decimal this way, you have to move it once past the 4, and then you have 6 spots to move it. 1, 2, 3, 4, 5, 6. So negative exponents are making the number smaller. Let me move this way to get some space. Oh, there's no space anywhere. So, here's something to remember. Negative exponents make the number small, okay? And the decimal moves left. Positive exponents make the number large, and the decimal moves right. Now, one more thing before I wrap up this video. When you multiply numbers that have exponents, so if you had 3 times 10 to the third times 4 times 10 to the third, what you would do is multiply this you multiply the I can't remember the term for it. You multiply the number in the front, and then you add the exponents. So you're going to end up with 3 times 4, that's 12, times 10 to the 6. Here's the thing with scientific notation, it has to be between 1 and 10. So we need to move this decimal right here, because we need to make this smaller. So it'll be 1.2 times 10 to the 7th. I wish we had a chance to practice this more, but if you move the decimal left to make scientific notations, then it is increasing the exponent. We divide. So if you had we had a number, let me count a number. Let's do 9 times 10 to the 5th divided by 3 times 10 to the 2nd. Well, you divide these as usual, but then you subtract the exponents. So it would equal 3 times 10 to the 3rd.